A heart beats every second. The earth turns every day. There's a full moon once a month. And the seasons change in a yearly cycle. What happens to these earth clocks when we leave our planet behind? What clocks keep time in the universe beyond? In the 20th century, the science fiction writer Arthur C. Clarke described an elevator that could take astronauts into space. Imagine his dream coming true in the late 21st century on Mount Kilimanjaro. A gigantic extinct volcano in East Africa, close to the Earth's equator. Mount Kilimanjaro was born 1.5 million years ago, and its summit is Africa's highest peak. The Clarke Space Elevator Complex would fill the volcano's summit crater. Each tower would be a docking bay for a space elevator cabin. A cable would connect the towers to an elevator terminal in orbit, 35,000 kilometers above. Imagine that the space elevator complex is real. The future is now, and your elevator cabin is ready for boarding. Your pre-trip briefing is about to begin in the glass-walled visitor center between the gantry towers. It's time for tomorrow.
Welcome to the visitor center of the Clarke Space Elevator on Mount Kilimanjaro. Please, make yourselves comfortable as we explain how the space elevator works. Outside these glass windows, you can see the 2 launch towers for the elevator complex and the sun just rising along the eastern horizon. In just a few minutes, you'll enter the tower to your right and board the space elevator. You can see nanofiber cables extending towards space from each tower. These ultra-strong cables connect under this building and in space to create one giant loop. While one part of the cable carries your elevator to orbit, the other cable is bringing the second elevator cabin back to Earth. This briefing explains the science behind this new era in safe and affordable spaceflight. In the 20th century, astronauts traveled into space atop ignited rockets with the downward rushing gases propelling the spacecraft upward. Spaceflight was very dangerous and required years of training. With the space elevator, there are no exploding fuels. Inside the cabin, the ride is smooth, the acceleration is minimal, and no training is required. Your elevator's observation deck has windows facing outward and downward, so you can watch Mount Kilimanjaro growing smaller as you leave the Earth behind. As you approach the orbiting space elevator terminal, you will see the docking bay for the elevator. The tall tower contains the hotel and offices of staff who live and work in the terminal and on the nearby time telescope. The ring area of the space station contains the repair shops and construction facilities to keep the elevator and telescope in good working order. Your trip also includes a visit to the Einstein Time Telescope, which lies next to the elevator platform. This incredible telescope uses Einstein's physics and a wormhole encased in a lens structure to see through time. Normally, when we look at an object, we see it as it was many thousands or millions of years ago, because it takes light that long to travel from the object to us. The Einstein Time Telescope removes this distance factor, so you can see distant objects as they appear from Earth and as they are right now. Astronomers, and now the public, can visit this telescope because of the Clarke Space Elevator. This time telescope is the ultimate adventure through time, an adventure that you began when you traveled to Mount Kilimanjaro. Africa is a continent linked to the history of time. Modern humans began migrations from East Africa to the other continents about 200,000 years ago. Now another African migration has begun as humans leave the Earth for space from this African spaceport. On Earth, we keep Earth time. Our bodies evolved with the programming of Earth's time cycles. As the Earth rotates once on its axis, the planet's surface moves from sunlight into darkness and back into sunlight again, causing our 24-hour clock cycle. You can watch day and night on the Earth below during your ride on the space elevator. Keeping this day-night time cycle has been challenging during spaceflight. On the International Space Station in low Earth orbit, astronauts see a sunrise every 90 minutes, 16 day and night cycles every 24 hours. Yet they're programmed for one sunrise every 24 hours. On the space elevator, we have the luxury of 24-hour days all the way up to geosynchronous orbit. Our astronauts on the Moon face a different time cycle challenge. The Moon's surface has 2 weeks of sunlight, followed by 2 weeks of darkness. Lunar astronauts must create daylight when it's dark outside and nighttime during the long lunar day. You will see another of Earth's time cycles on your space elevator journey. By the second day of your trip, you will see that Europe is much greener than southern Africa this time of year. In July, the sun is much higher in the sky north of our equatorial launch site. If you were to visit us in December, you would see summer greenery in South Africa and winter snows in Europe. We can keep all of our familiar Earth clocks on our trip on the space elevator because our elevator remains directly over Mount Kilimanjaro. Our day, month, and year are exactly the same as those experienced on the Earth below. Speaking of time, it's now time to board the space elevator. Your astronaut guide is waiting on the elevator pad.
Welcome to the departure bay of the Clark Space Elevator. Cargo has been loaded in the storage decks, and the elevator is ready for passengers. As you enter the elevator's observation deck, please move toward the end of each row. Take a seat, engage your shoulder harness, and prepare for ascent. The ground latches are being withdrawn as the elevator prepares to leave Earth. As we climb, you'll feel lighter and lighter until you're floating off your seat when we're in orbit. On either side of the elevator cabin are detachable life pods, capable of gliding through the atmosphere and returning passengers safely to the Earth's surface. There are enough life pods to carry all passengers to safety. The space elevator is so safe that I've never seen these deployed.
Cable engaged. Begin ascent operations.
The other cabin has been released from the orbiting terminal above us. Its fall is now pulling us slowly upward. You'll feel a gradual acceleration until the elevator reaches climbing speed. Watch as we clear the station gantry.
Time in transit, 4 hours. Distance from Earth terminal, 2,000 kilometers.
The elevator cable arcs towards space, allowing us to look down at the Earth. You can see Mount Kilimanjaro growing smaller below us. As the Earth turns eastward under the sun, daylight is coming to the world below us. The Arabian Peninsula is at the top of our Earth view. Below it, we can see the Horn of Africa and our launch site on Mount Kilimanjaro. The eastward turning Earth has brought daylight to all of the African continent.
Good morning. It's day 2 of ascent. Time in transit, 24 hours. Distance from Earth terminal, 11,700 kilometers.
Good morning. It's day 2 of our elevator ride. We're now so far above the Earth that we can easily see the whole planet below. We're looking eastward over the Indian Ocean. The island of Madagascar lies just off the African coast. From the observation deck, we can see the sun in the distance. Since we're less protected from the sun's radiation on the elevator, we must monitor the sun's activity continuously using video feeds from solar telescopes on Earth and in space. Today's sun shows many dark sunspot groups, each marking a region of solar storms and heightened activity.
Warning, warning. A sunspot group has just produced a large flare.
A storm of charged particles has been ejected into the solar wind and has been detected moving toward Earth. But don't be alarmed. We have the Earth's magnetic field to protect us. We are very close to maximum in the Sun's 11-year sunspot cycle. This level of solar flare activity is normal.
Approaching midpoint of ascent. Time in transit, 36 hours.
We've reached the midpoint of our trip. Below, we can see the sun setting over the Sahara Desert. The high sun of summer brings incredible heat to this vast desert, covering much of northern Africa.
Good morning. It's the end of day 3 of ascent. Time in transit, 72 hours. Distance from Earth terminal, 35,000 kilometers. Stand by for cabin docking. Contact geosynchronous orbit achieved.
This terminal has a dormitory, cafeteria, and a small shop for the convenience of astronomers, astronauts, and overnight guests. Laboratories and workshops require special access. The Einstein Time Telescope hovers above the cableway. Soon, you will reach the docking port for the telescope shuttle. The shuttle has been prepared and is ready for your arrival.
Welcome to the observation shuttle for the Einstein Time Telescope. Today we'll be photographing distant objects that show dramatic changes over time. Please take your seats inside the shuttle. I'll explain telescope operations as we leave the elevator terminal and approach the telescope's docking ring. The Time Telescope looks like a giant lens, a very special lens with a wormhole at its center. The mounting ring has small maneuvering engines to turn the telescope toward any object in the heavens.
The telescope is now pointed toward a spiral galaxy called M51, 31 million light years away and containing billions of stars. When we engage the wormhole, the telescope bends space to create a shortcut for light to follow, a wormhole tunnel between us and the distant galaxy. This is how M51 really looks today. There are very few changes. For a galaxy, 31 million years is a short period of time. To see more time pass, we must find an object that is much farther away. This cluster has become a gravity lens, bending light towards us from more distant galaxies. This object dates back to a time just after the Big Bang explosion that started the universe on an expansion that continues today.
As the universe began to cool, the first matter called quarks formed. Over millions of years, the quarks combined and turned into the nuclei of hydrogen and helium atoms. These charged particles collected into young, hot stars. These stars grew old quickly, and in death they exploded and enriched the universe with heavier elements like carbon and oxygen. Gradually, the universe cooled, and spinning clouds turned into the familiar shapes of galaxies. By warping space, we've seen the beginning of time. Now, let's see if we can bend space just enough to see the birth of individual stars. I'm slewing the telescope to M33, a nearby spiral galaxy in the constellation Triangulum. This galaxy has a massive star birth cloud called NGC 604. The NGC 604 nebula is over 2 million light-years away. The stars inside look very young. Through the wormhole, we can see how this cloud will change over the next 2 million years. As we bend space, we see stars being born. This is a birthplace of stars, a stellar incubator. The light of these new stars will not reach Earth for millions of years. Like humans, stars have a life cycle, and this birth cloud is just the beginning. Stars also grow old and die. To see this, we must visit another kind of cloud, a cloud that is really a star's death shroud. I'm scanning the constellation Carina for a famous nebula called Eta Carina. This is really a massive, unstable star. It cannot survive very long as we see it now. Through the wormhole, we can watch this star change as we move forward in time. The star is exploding, just as we predicted. Eta Carina does die in an incredible supernova explosion that destroys the star, leaving only a pulsing neutron star behind. In this explosion, Eta Carina will become so bright that people on Earth will see it in the daytime, when the light of the explosion reaches Earth in about 4,000 years. When we see Eta Carina from Earth today, we're really seeing an object that has already died. Just as stars begin from gas and dust, the cycle is complete when they return their gas and dust to the universe. The alarm warns that a solar flare could happen at any moment. I'm slewing the telescope to the sun, only 8 light minutes away in the constellation Cancer. Through the time telescope, we can see the sun 8 minutes before its light reaches Earth, an extra 8 minutes of warning if a flare explodes. Wow! There it goes! This is the second giant flare in 3 days. This is very rare and very dangerous. The earlier flare has compressed the Earth's protective magnetosphere so much that we are no longer shielded, leaving humans at the time telescope and on the space elevator terminal exposed to dangerous particles of the solar wind. The high-energy radiation will reach us in just a few minutes, and the radiation belts will build rapidly over the next few days. We must evacuate the telescope immediately. The telescope must be stowed for its own protection during the period of high solar radiation. This viewing pod will carry you back to the elevator terminal, and your astronaut guide will instruct you on descent procedures. Move quickly, and you will be safe.
Everyone, please proceed to the space elevator. The elevator cabin has been prepared for immediate departure. We must drop below the Van Allen radiation belts for maximum protection before most of the solar particles arrive. Please, take your seats quickly and fasten your safety harnesses. All windows have been closed for maximum shielding as we descend.
Docking clamps disengaged. Elevator descent initiated.
While we descend, the permanent station crew are securing the terminal and the time telescope. All sensitive electronics must be shielded from the approaching solar storm. The second elevator cabin has just been released from the Kilimanjaro ground station. It's bringing repair equipment and may be needed to transport any crew harmed by the solar storm.
Time in transit, 24 hours. Prepare to pass the empty ascent cabin.
We have just passed the rising elevator cabin. We are halfway to safety on the Earth's surface.
Time in transit, 40 hours. Van Allen belt transit successful. Elevator speed in excess of safe docking with current passenger loading.
Passengers, you must board the life pods. Your pod will detach from the elevator, and an astronaut will pilot and land your craft. Passengers, please buckle shoulder harnesses and seat restraints. Our entry trajectory is set. It's time to hang on for the flight of your life. Welcome back to Earth. All gliders have landed safely. Looks like we made it back just in time.
Your space elevator ride is just another step in our cosmic journey. Imagine all of time happening in one cosmic day. At midnight, the universe begins in a Big Bang explosion. Before 7 a.m., the Milky Way galaxy forms. Just after 3 p.m., the Sun and its planets are born. By 6 p.m., Earth life has appeared. Just after 11 p.m., plants first live on land. Less than a second before midnight, humans appear in Africa. In the last 10,000ths of a second before midnight, Egyptians invent the modern solar calendar. At midnight of this first cosmic day, humans live in orbiting space stations. Perhaps we will begin the second cosmic day, leaving Earth on a space elevator and seeing the universe in real time. After all, it's all about time.